Welcome to our new unit. This unit deals with systems of equations. Today we're going to take a look at solving linear systems by graphing. So our goal is to determine how to solve a system of equations graphically with and without technology. So a linear system is a pair of linear equations. And remember that linear equations are equations that when we graph them, we get lines. So all the work we've been doing with y equals mx plus b, those are all linear equations that we're working with. The idea for these questions is to find the point where the two lines meet. These types of questions apply to real-life situations like aviation and economics. So pretty wide range of situations that this applies to. So when you're asked to solve a system of equations, you need to find the point of intersection. And we just use the short form POI to represent point of intersection. So in this unit, we're going to take a look at three different methods for finding the point of intersection. Today, we're going to take a look at finding the point of intersection by graphing. The second method is called substitution. And the third method is called elimination. So, because we're focusing on graphing today, I just want to talk a little bit about the advantages and disadvantages of using graphing as the method to find the point of intersection. So, advantages, when you graph the two lines, it's easy to see the answer. Especially if the lines are parallel or overlap. And we'll talk more about those situations down below here. Disadvantages. Now this will be a shock. Not everyone enjoys graphing. I love graphing, so I can't imagine that there are actually people in this world who don't enjoy graphing, but there are some. Another disadvantage is that the point of intersection is difficult to identify if the lines are not graphed accurately. So when you're graphing, it's very important that when you draw your line through 2 points, for instance, that you draw the line right through the middle of those points. Because if one of the lines is slightly off, then it's going to be hard to identify the actual point of intersection. Okay? So there's three different situations we can run into when we graph two lines on a graph. We can have a situation where there is one point of intersection. So there is the one point where those two lines cross. We can have a situation where there is no point of intersection. So you can see we've got these two parallel lines and they never cross each other. So they have no point of intersection, so there's no solution there. And then there is the case where we have many points of intersection. So in this graph, there are two lines graphed, but the two lines are exactly the same lines. They overlap each other. Then that means that they intersect on every point on the line. So it's like an infinite number of solutions in that case. Okay, so just a reminder for this graphing, and I know we just finished working on all this stuff, so I'm sure it's fresh in your mind. Remember our equation y equals mx plus b. M represents the slope, and b represents the y-intercept, or when x is equal to 0 on the graph. Okay, so let's look at some examples and see how this actually works. So it says solve the following system of equations. So we're given these two equations. Okay, we'll call this equation 1 and equation 2. And really it's two questions in one, because we're going to graph each of these lines on the same graph and then figure out where they cross. So in the first one here, I can identify the slope. So the slope is -2 over 1. B is equal to 6. So that means the point 0.06 the line will go through. So let's go ahead and graph that one to start with. So remember, we start with the y-intercept. So 1, 2, 3, 4, 5, 6. So there's my y-intercept. And then I count my slope. Remember that our slope is rise over run. So if I rise -2, that means I go down 2, and then I run 1. So that gives me that point there. And then I can draw my line through those 2 points. Okay, now I'm going to have to fix my line here to make sure it's going through the proper spot. Okay, that looks better. I'll put arrowheads on the end. And it's really important when we draw these lines that that we extend the line to fill the graph, because we don't know where the two lines are going to intersect. So you don't want to stop the line in the middle of the graph. You want to fill the grid with your line. Okay, so there's that one. The second one here, I'm going to rearrange this equation to get it in y equals mx plus b form. And once I've done that, the slope is -1 over 1. So when we've got that negative in front of the x, it's like -1. And b is equal to 2, so that's the point 0.2. Okay, so I go to 0.2 to start with. And then from that point, my rise is -1 and my run is 1. So I go down 1 and run 1. And I'll draw my line through those 2 points. Okay, let me just extend this line. Okay, and I'll put my arrowheads on the end here and here, and that line is x plus y equals 2. You should label your lines in the graph if you're graphing more than one line on the same graph, so it's clear which is which. Now, you can see I did a pretty good job of drawing these lines through the center of the points, but I'm slightly off. This point of intersection here should be over to the left a little bit here. So I get that point there, and that is my point of intersection. So POI is, and that point is 4, -2. Now, I can check to see if that is the correct answer. So I'm just going to show you how you can check your answer to be sure. So remember that that is the point that is common to both lines. So if it's on both those lines, that point should work in both equations. So I'm going to check for point 4, -2 to see if that is, in fact, the correct answer there. Because my graph doesn't quite show that. It looks like it's a little bit off of 4, -2. So in the first equation, I'm going to sub in 4 in for x and see if I get -2 for y. So in the first equation, it's going to be y equals -2, 4 plus 6. Y equals -8 plus 6. So y equals -2. So that point is on that line. So that's good. Now we'll go into the other equation and we'll plug 4 in for x in that one. So when I substitute 4 in for the x, I get 4 plus y equals 2. I get y equals 2 minus 4, and I get -2. So even though I haven't drawn the lines to go perfectly through 4, -2, I can check my answer the way I've shown there, and that proves that our answer is correct. Okay, let's do the second example here. All right, so this one here, the slope is 1/1. B is 2, so that's 0, 2. So I go to 2 on the y-axis, and then from there, I rise 1 and run 1. And then I draw my line through those 2 points. I'll extend that line. And it's going to look like that. Good. Okay, so that's y equals x plus 2. And now the other line. So this one I've got to do some rearranging to get it in slope y-intercept form. So I'll move the 4x to the other side. It changes to -4x. And then remember, when we get to this point, we're going to divide each part by 3 here. And that gets rid of the 3 here, so that's just going to be y. But both parts on the other side get divided by 3. So that's what we end up with when we simplify. So that means that m is -4/3, and b is -5. So my y-intercept is going to be 0, -5, 1, 2, 3, 4, 5. And then from there, I go down 4 and over 3. Oh, that's not going to be very good. If I'm down 4 and over 3 here, that's the same as going back 3 and up 1, 2, 3, 4. Because that's going to end up going in the same direction as the other point that would have ended up down here that was off our grid. So remember, the great thing about lines is that the pattern continues. So you can kind of work backwards there to find a point on the grid to help draw the line. Okay, so that looks like that. We'll put our arrowheads there, and that's the line 4x plus 3y equals -15. So there is our point of intersection. So POI is, and it's -3, -1. Okay? Example 3, you guys can go ahead and try example 3 on your own. We'll take it up at the beginning of class tomorrow, and then we'll get an opportunity to practice this stuff. Okay? We'll see you tomorrow.